Hello, everyone. My name is Ido. By the way, how many of you came here from my WCF 4.5 session hoping for a rerun? Okay, my machine has cooled down a bit. Yeah, for those of you who haven't been in my session, I had a session earlier about WCF 4.5. My machine got too warm. It reached about 95 Celsius, and it just shut down a couple of the processors on the machine, and nothing worked. But now it should be okay. So if you want after the session, join me and we'll do a group session and I'll show you all the demos that I didn't show before. If you have a Twitter account, just search for the GIDS hash and you'll see a couple of screenshots I uploaded with some of the demos. But we're not here to talk about WCF 4.5, we're here to talk about WCF 4. And so for those of you who haven't been in my session in the morning, my name is Ido Flatow. I come to you from Israel. Yeah, it's a long place far away. I'm a Microsoft MVP for Connected Systems. I wrote the WCF4 course for Microsoft a year and a half ago. And I do a lot of work not only about WCF, but about ASP.NET, Silverlight, Internet Explorer, Entity Framework, IIS, a lot of stuff. And let's talk a bit about WCF. WCF, World CAT Federation, or wait a minute, no, that's not the right slide. Sorry. WCF, Windows Communication Foundation, was originally conceived in 2005. It was called Indigo once. Since then, we know of the new releases in .NET 3.5 and in .NET 4. And for those of you who have been in a session this morning, there's also already .NET 4.5 in beta version, where you have all sorts of cool features. And WCF is not just about writing services. WCF, I'm missing something here. Yeah. WCF is an infrastructure. And as such, it is a base for different infrastructures such as WCF REST services, WCF data services. Anyone using WCF data services? No? Okay. It was released in version 5 last week. And WCF can be used everywhere. You don't have to be .NET developers. You can also use Java. Okay, so if you are Java developers who will be attending GIDS Java tomorrow, you are able to use WCF from Java, from native C++, or even from browsers, JavaScript, and even from PHP if you want. Okay, so the things that we're going to talk about regarding WCF4, we're going to talk about configuration, we're going to talk about IIS and web HTTP services, we're going to talk about routing services, and we're going to talk a lot of other stuff that are new in WCF4. And first of all, for those of you who are using WCF4 today or WCF 3.5, how many people here don't use WCF? Don't use WCF at all? Okay, WCF 3.5? Okay, and WCF4? WCF 5? No, you didn't hear me say that. There's no WCF 5. Okay, so in WCF 3.5, WCF4, less in WCF 4.5 if you've been to my session, building service configuration in WCF, whether it's 3.5 or sometimes even 4, it can be a bit of an annoyance. Okay, you always copy-paste stuff from one place to the other. You had a standard way of defining a basic HTTP endpoint with the binding configuration that you used to have in your project, and you just copy the same configuration all over again from one project to the other, right? You had that feeling, yeah? You open your older project, copy the configuration to a new project, and then start creating your service. Well, in WCF 3.5, we also have large amount of configuration. So if you want a basic HTTP endpoint and a WS HTTP endpoint, and the service behavior that does one thing, for example, exposes metadata, and another service behavior that doesn't expose metadata, you'll get something that looks like this, right? How many people have this kind of WCF configuration in their code? Right, a lot of us. So in WCF 4, some changes have been made to make this thing easier. So first of all, we have new default configuration sections. You don't have to have a name for each of your binding configuration. You don't have to have a name for each of your service behavior. Okay, you can define a default service behavior, a default binding configuration, and every time you define an endpoint that uses a specific binding, or you define a service okay, you actually get a default configuration that you can set in advance. Okay? No need anymore for binding configuration names and that sort of stuff. You get standard endpoints. So for example, anyone here uses MEX endpoints, metadata exchange? MEX endpoints? One. You don't need to do that anymore. Okay? You can use a standard endpoint. There is a new attribute when you define an endpoint. It's called kind, K-I-N-D, kind. And you simply tell it, please, I want this endpoint to be of kind metadata exchange, and it will define automatically the binding, the contract, and even the address if it has a default address. Okay? You can define standard endpoints of your own. I'll show you a sample in a couple of minutes. And you also have default endpoints. So for example, how many of you always use a standard endpoint, such as a basic HTTP binding or a WS-HTTP binding, right? We always use some sort of a default endpoint in each and any one of our projects, and we just copy-paste it all over again. In WCF4, you don't need to define that endpoint. In WCF4, if you don't define any endpoints, you get default endpoints. And you can configure how those default endpoints will be created, which binding they will use, which binding configuration they will use. You get a default endpoint for each of your base addresses automatically. Any developers using IIS as a hosting environment? Yeah? Well, from now on, your web config will be empty of any WCF configuration. You just don't need it. It will be default automatically. Okay? So let's go ahead and see some of it. Just open here a solution. Let me just open Visual Studio. Don't worry if you've been to my WCF 4.5 session. My machine has cooled down. It is now at only 72 Celsius. It was 87 before. Okay, so you can understand why it didn't work. Let me just start another Visual Studio here and we'll see it running. Okay. Okay, so what we have here is the following. Where is my program? Okay, so first of all, let's talk a bit about default endpoints. I want to show you this one. And default endpoints, as you can see, I'm trying to host a new service called product service. Okay, this is an auction arena application. It has a product service, a bid service, auction service. So this one is a product service. It's a service that allows us to get information about products. And as you can see, I'm using two base addresses here in my constructor, an HTTP one and an TCP. Okay, two base addresses, and I'm opening the host. If we look at the configuration, if we look for product service, you'll notice in my app config, that this service is not a product service, and this service is not a product service. I actually have no product service configuration. Now, how many of you are using WCF 3.5? Okay, what will happen if I run this code in WCF 3.5? I will get an exception because there is no, there are 0 endpoint configurations for the service or some of that sort. Now, if I run this code with WCF4, you can say automatically get 2 endpoints, one that uses HTTP, another one that uses NetTCP. Okay, I actually got 2 endpoints according to the base addresses I used to define my service host. Okay, now this address is using WS HTTP binding. Let's say I want to change that default. Okay, what I can do is I can simply go. Now what? This wasn't the default. This is the default. The default is basic HTTP binding. Okay, the default is basic HTTP binding. If I want to change that default, all I need to do is add a protocol mapping element. Protocol mapping allows us to map between a scheme, HTTP, NetTCP, named pipes, MSMQ, whatever you use in your code, and map that scheme to a default binding, and if you want, to a default binding configuration. Okay? So I can use WS HTTP binding instead of the default basic HTTP binding. I can change the maximum message size of my WCF service. I can do a lot of changes, and simply when I run it, the default mapping changes from HTTP, basic HTTP, to WS HTTP. Okay? if you're using IIS, you already get default endpoints according to the HTTP or HTTPS bindings that you use in IIS. If you want, you can just plug in a protocol mapping, change everything to WS-HTTP binding, and you get all your endpoints. Okay? If you have a service that exposes several contracts, you get an endpoint for each of the contracts. Okay? So if that service, the product service, would implement 2 contracts, I would have got 4 endpoints. Okay? 2 for each contract, HTTP and TCP. Now I want to show you a cool thing about the new features of the configuration, and that is creating default endpoints of your own, standard endpoints, sorry. So in this case, as you can see, I'm hosting a bid service. It's a different service. Actually does nothing behind the scenes, but doesn't matter. There is only a base address using HTTP, but they do have configuration for this bid service. And this bid service is defined as follows. I have here a max endpoint. And as you can see, I don't need to define a binding and a contract. I can simply tell it that it's a max endpoint sort of endpoint. And I have a web HTTP endpoint. What is web HTTP? It's a REST endpoint. Okay, it doesn't use a SOAP. And I've got 2 NetTCP bindings. One is a basic NetTCP binding, uses the NetTCP binding sort of binding. And the other uses a special kind that I called NetTCP customized endpoint. This is actually a standard endpoint that I've written. And as you can see, there is an address, a contract. What is missing? ABC. Endpoint are ABC. Address, contract, and binding. Okay? So it's missing a binding. But I actually defined that binding in my customized endpoint class. You can create classes of your own that inherit from service endpoint. You override, you just need to create a constructor and define which binding you are using. So I'm using the NetTCP binding. I can also define a default contract that I want this endpoint to use. And I can define the binding configuration. So for example, here I define the max received message size to max value, which is something we always do in our services, right? Right? All of us increase the max received message size because the default, which is, anyone knows? 65K, right? 65K is not enough, okay? So in this case, I have the NetTCP binding, which uses 65K limit. I've got a customized endpoint, which is a NetTCP binding with, what is the max value? 2 gigs, I think, something like that. Let's run it and see. Okay, so I've got the metadata exchange, web HTTP binding, the TCP binding with 65K, and my TCP binding with 2.1 gigs. Okay, so where is it used as standard endpoint, the way that you can create your own standard endpoints? If you are building infrastructure for development teams, okay, and you want to tell them which endpoints to use, instead of telling them use WS-HTTP binding with that sort of security and that message size and those timeouts, simply give them a standard endpoint of your own, okay? And that's a really cool feature of WCF, especially if you're developing infrastructure services for other teams in your organizations. Okay, so let's talk a bit more about the new features of WCF4. Now, how many of you are using IIS to host your services? Okay, okay. Other are hosting Windows services, right? I'm guessing anyone hosting under a console? I'm not kidding you. I heard from someone that they are hosting the services in a console application, hoping that no one will go over to the server and just shut down the console. Strange, but they are moving to Windows services. So what do we have in IIS? First of all, do you know the SVC file that is created in each web application that uses WCF? Has anyone ever looked at that SVC file to see the content of it? It has a short string that tells IIS where is the service that it needs to host. Okay? In IIS now with WCF4, you don't need that file. You can write the same string in configuration, telling IIS exactly where your class is. If you have a special service host factor, you can tell it also, and you don't need that file anymore. Okay, so you can just take all your services, put them in a different assembly, and just host it under IIS using simply configuration. No need to create any SVC files. Okay. In addition, WCF4 supports compression. So if you have client applications that receive a lot of data and the service is hosted under IIS. Until now, those clients never send the HTTP header that allows IIS to compress the data. You know, if you want to allow IIS to compress the data, you need to send it a special header for encoding that tells it you can compress it, I can understand gzip. Okay? In WCF4, clients, the proxies of the clients actually send that header, and IIS can compress the information it sends back to the client. So even if you're using SOAP, using textual XML, you can use the encoding, the dynamic compression of IIS and reduce your message sizes by about 30%. Okay? From 100K, say, per message to 70, 60K, even lower than that. So it doesn't require any change to the bindings. Simply change your client application to use WCF4. It will automatically work. I'll show you a demo in a couple of minutes. Okay? It just works. You just need to configure your IIS to support compression. That's it. Okay? And we have another support. Anyone uses web farms in their IIS servers? Hosting several IIS servers under a cluster. When you do that and you try to add a service reference to a service hosted in IIS, the service says WSDL file. You're familiar with the WSDL file? Yeah. The WSDL file, in it there is the name of the machine that hosts the service. Now, if you're working on a single machine, that's not a problem because you add the service reference to the remote machine and you get in the WSDL the name of that machine. If you're working in a web farm, you don't want to get the name of the physical machine. You want to get the name of the farm, of the load balancer. Okay, because you reach a single server and from there you navigate it to one of the servers in the farm. In WCF4, IIS automatically takes the name of the machine you wrote in the URL, okay, and that is the name it uses to create the address of each and every one of the endpoints. Okay, so you don't need to hard code the name of your load balancer into your web config files before uploading it to the web servers. You simply can leave the local host there, and it will replace that local host with the name of the load balancer according to the URL your users are using. Okay, so that's very nice. And another addition is the Windows Server App Fabric. Anyone ever used App Fabric hosting in IIS? App Fabric hosting actually doesn't give you that much. It gives you a lot of monitoring. So you can get events from WCF, log them into SQL Server, and then get statistical information about your services. We'll see that in a couple of minutes. Another thing that has to do with HTTP is the use of web HTTP services in WCF. How many of you have heard of the term called REST? R-E-S-T. Okay. REST is a way to, let's say, how should I put it? REST is an architectural style. Okay. It allows you to take all of the advantages of HTTP, the verbs, get, put, post, the headers, the caching headers, the content type headers, and use them in order to convey information to a service. For example, if I'm doing an HTTP GET, that means I want to get something from the service. If I'm doing an HTTP POST, that implies that I want to take something from that message's body and put it on the server side, meaning I want to do an update, I want to do an insert. If my content type says I'm expecting an image file, that should imply to the service that the service should return an image file. Okay? If I would have written there XML as a content type, I probably expect the service to return an XML of that entity. If I'm doing an image, maybe I need an image of that entity. Okay? For example, a product. I want an image of the product and not the XML that describes the product. Okay? I can use headers to define caching. So this is the concept of REST. Use HTTP to deliver information to your service instead of using SOAP. REST doesn't use SOAP at all. Okay? And REST is used in a lot of places. There is even a new API for ASP.NET called the ASP.NET Web API to create RESTful services. But WCF was the first. And WCF actually supports a couple of types, a couple of types of content types when you create RESTful services. You can use plain XML. You can use JSON. Anyone here is a web developer, uses JSON in JavaScript? Yeah? Okay, a bunch of you. And you can even return binary content. For example, you can return an image. You can return a video file through that service. Okay? So that wasn't available all the time in WCF. Actually, REST started in WCF 3.5, but it's quite lame. So Microsoft released a toolkit called the WCF 3.5 REST Starter Kit. Unfortunately, it was never released. It's always been in a preview release, okay? So they haven't really released it officially, so you can't use it in production. Although I did see some Microsoft products that were released where they put the REST Starter Kit binary in them, okay? So you can't use it because it's not RTM, but Microsoft does use it in their own products, okay? So that REST Starter Kit was migrated to WCF4. Most of the features of the REST Starter Kit are also in WCF4. For example, help pages. REST is not SOAP. Therefore, you cannot use a WSDL file. Therefore, there must be something else that describes your service, and there are help files to do that. Second, you can use response formats. So I can select in my service which type of format I want to return, an XML, a JSON, something else. I can control that. Error handling. I have no SOAP. I have no faults. I must return errors in some other way. I can't always return HTTP 500. I need to give a reason. Maybe my reason is that the data doesn't exist. So I don't want to return an HTTP 500. I want to return an HTTP, which code? 404, okay? Or if the user is unauthorized to access that entity, I can maybe return an HTTP 401, okay? So I can use error handling, special error handling. I can use the ASP.NET mechanisms for caching. I can use the ASP.NET mechanisms for routing and actually remove the .svc from my services URL, okay? I can use caching in order to tell the browser to cache that JSON object that I'm returning to it and not request it again every time, okay? And if you are familiar with JSON, you have JSON-P, which is for cross-domain calls, which is also supported in WCF, okay? So let's see a bit of these demos, and to show you those demos, I will need to start Fiddler. Are you familiar with Fiddler, the web debugger? Okay. Fiddler is a sniffer. It's an HTTP sniffer. It's much more than an HTTP sniffer. This is why it's called a web debugger. But currently we'll use it as a sniffer. If you're interested, come to me after the session. I'll give you a link that you can download the presentation I had about Fiddler and about all of its features. It takes a whole day to talk about all the features of Fiddler, so we don't have time now. Okay. But let's take a look about REST services. And for now, this is a small application. Remember the auction service I had before? Okay. So right now, let me just remove this one. Right now, we have an auction website, sort of an auction website. I have 3 products here that I can sell. Windows Phone 7, desktop PC, and a laptop. Anyone interested? It's cheap? No? Okay. And when I click the link, I get an image of the product and a list of auctions when that product is going to be auctioned, okay? I can click the desktop PC, the laptop, and everything you see here, all the data, the list of products, the updated date, the image, the list of auction dates, these are all service calls. Service calls that return either XML, JSON, images, okay? Let's see how it's done. So, first of all, let's take a look at the service. Where is it? Okay, so first of all, to those of you with keen eyes, I don't have an SVC file here. Okay. Actually, my entire service configuration is this line. Service activation, I tell it the address of the service. This is called auction.svc. Okay. And it's using the auction service type. That's it. That's the SVC file that we had before. Okay. Now it just moves from being a file to configuration. Simple as that. Okay. And my service actually has the following settings. So first of all, to get, for example, the list of products, okay, that Windows Phone, that desktop PC, and the laptop, I have a get products service call. That get products, if we'll take a look how it's defined in the contract, we'll see that get products is a, it doesn't have an operation contract on it because it's not a SOAP contract, okay? it has a web-get attribute. Web-get attribute tells that service that this operation, get products, is actually using HTTP GET. Simple as that. If I don't want GET, if I want to do a sort of an update product or remove product, I'm simply going to change web-get, for example, to web invoke, and specify the method, whether it's post, put, delete, according to the thing I want to do. If I want to remove, I will use HTTP method of delete. Okay? And the URI template actually defines how to decipher the URI and understand which of the parameters the method expects, which of the parameters is placed where exactly in the URL. So for example, this category that I want to receive is actually one of the sections in the URL. So I'm expecting to see get product / some sort of category, which will return the list of products. And that list of product is using Entity Framework. I won't talk too much about Entity Framework. And the response format is actually defined according to the query string. Okay, if there is a query parameter named format in the query string, I simply check if the client wants to use JSON or XML, and according to that, I'm changing the response format of my contract. Okay, so for example, let's find that list of products in get products. Here you go. Get products computer. Okay, it is compressed. So as you can see, I'm getting a JSON-P here. Okay, this is a JSON-P string. For those of you who know a bit about JSON, this is a JSON object notation. Okay, JavaScript object notation. Now, if I want to change this to return an XML, no problem. Let me just compose this message and remove this part and change the format to XML. Okay, and now the format is XML. Simple as that. Okay, so if you're working from a browser, you'll probably want a format that uses JSON. If you're working from a .NET application with simple HTTP, you can just pass format XML. Okay, I go and seek that image. I'm getting back a stream. Okay, there's a file somewhere that contains that image. I'm getting that stream, and I'm simply changing the content type manually to image/PNG. Okay, and I'm returning. Observe, I'm returning a stream. Okay, so I don't actually need to convert it into an XML base64 arrays. I don't need to send it as some sort of a byte. I'm just returning a stream, a simple stream, and the REST service will return that image simply as that without any wrapping XML elements. And for example, if I want to take a look at it, it looks like so. Okay, can you read binary? No? Okay, so maybe that will help. Okay, that's the image. Okay, if I go here, if I go to this one and this one. Okay, simple as that. Plain images. Okay, so this is the kind of things that you can do using REST services. Simple, non-SOAP services that accept URLs, simple URLs, using GET, using POST, and return any kind of content you want. Okay. Let's talk a bit about a new feature of WCF. Now I want to show you a question and tell me what you think. So I have a new service and an old version of the service. Okay, I have, for example, some service that returns census information, and until 2010 it used the mainframe and I don't know, a second level database, I don't know, a natural database or something like that, DBase, I don't know. And the new version uses SQL Server, uses, I don't know, Azure, uses WCF, okay? And the new service is located at a specific address. The old service is located at a different address. Both are WCF, but both have different addresses. And if I want from a client to get information for census information of, let's say, 2005 and 2010, I actually need to put the logic in my client so I will know which address to use, right? If I want to get the client to talk to the new service, I have to tell the client the address of the new service. If I want the client to address the old service, I need to give it that address. Meaning the business logic of where each service resides, which service deals with which information, is a part of the client business logic. And that shouldn't be like that, because the client can be any type of client. I don't want to tell them that I have actually two services. I want them to think that I have one service and want my service to do all of that decisions where to go to get the data. Okay? So usually we build another service, right? Told the client to access that service, and our service opened a connection to a different service. Now there is a new way of doing that in WCF4, and that is by using a new type of service called a routing service. Okay? A routing service can actually receive requests for a service, doesn't matter which contract, and according to the content of that request, decide where to send that request to. It can be service A, it can be service C, it can change the binding on the way. So for example, it can receive the request on HTTP and pass it through to the target service on TCP. Okay? It can even do one-way requests, duplex requests. It simply creates a routing mechanism for WCF based on the content of the message. Okay? So unlike routing mechanisms such as load balancers and that sort of stuff, service buses, a routing service in WCF is based on the content of the message. It uses filters to decide where to send the message to. Okay? According to the address, according to the content of the message, you can even write an XPath that searches the content to understand where that message is going to be sent to. Okay? It supports different message types, one-way, request response, even duplex. Okay? And you can even change the protocol as I described to you. You can receive something over HTTP and push it over name pipes. Okay? And everything in this service is through configuration. So I want to show you that service. And I actually created the demo that shows exactly what I showed in the diagram. I have here a client, a new version of the service, an older version of the service, and the routing service. Okay? So I'll just start the client. The client now wants to get information for 2004. Okay? So it calls the routing service. The routing service receives the request and pushes it to the old version. Now the client will like to get information for 2010. It sends, oops, yeah, what happened? Okay, it sent a message, I pressed space twice accidentally. It sends a message, but this time the new version gets that message. Okay, so let me do that again just to show you how it was done. Run it. Okay, the client first sent the message to the old version. You should see it in a second. Okay, and now I'm sending it to the 2010, and it got to the new version of the service. How did I actually do that? Well, that's quite simple. So first of all, the client needs to know only one address, the address of the routing service. Okay? So I gave you the address of the routing service. This is the address of the routing service. The routing service actually does nothing. The routing service itself is a special service. I'm creating a service host and I'm hosting a special WCF service called a routing service. Okay? And that service is responsible for all of the routing itself. How is it done? So first of all, this routing service uses request-reply connection. It doesn't need to know the contract of your target service. It can handle any type of contract. Simply tell it if it's a one-way, a two-way, a duplex, or a request-response. Okay? So this one is a request-response, a request-reply. And the configuration is here. So first of all, I'm using a special filter table. This is the name. We can look for it here. This filter table has two filters, one for V1 and one for version 2 of the service. It uses two filters, and the filters are, if the census year is less than 2008, please use service V1. If the census year is larger than 2009, use the second service. Okay? This is actually an XPath that checks the content of the request. What is the census RQ? This is the name of the parameter the client sends. Okay, if I'm if I look at the contracts, you can see that this is actually the year the client sends. This is this parameter. If you look at the XML, you see that this is the request. Okay, sensors user request slash year, which is the parameter. Now, each of these service v1, service v2 is actually a client endpoint. Okay, I have a client endpoint called new service EP. This is the connection between service version 1 and the old service EP, service 2, and the new service EP. So when service v1 filter is okay, it actually uses, sorry, the old service EP, or was it the new? The old service EP. If v2 is okay, then it uses the new service EP, and simply note, the contract is an asterisk, meaning it doesn't care what the contract is. It just takes that message and pushes it to the target service. Okay? So this is the concept of a routing service. You can create a service, do all kinds of filtering. You can even write your own filter if you want to do some extensive check of the message itself. You can even do dynamic rules to change the rules during runtime. So for example, check if a service is turned on or not, and change the routing accordingly. Okay? During runtime, you can change this table. So this is the routing service. And of course, these are not the only new features of WCF4. I want to go over some of the other new features, but without slides and demos. First of all, throttling in WCF. WCF 3.5 has a very low throttling level. Throttling means how many concurrent calls your service can handle. Anyone knows the default in WCF 3.5? 10? It's 10 in sort of a way. WCF 3.5 allows you to use 16 concurrent requests in your service and 10 concurrent sessions in your service. Okay, there's a difference between a session, an idle session, and a current request that is being handled. In WCF4, these will change to 100 sessions by default, and 16 concurrent requests time the number of calls you have in your machine. So for example, if on my machine, I have 8 calls, and the default is 16, that means that I can accept 16 times 8. Anyone calculators? 16, 128 concurrent requests, okay? If you have a bigger machine, more CPUs, you can handle more concurrent requests as a default, okay? The reason the default is so low, 16, is because the WCF team wanted you to be aware that there is a throttling level which you need to test, okay? And now that's not what, I think that's what the product manager of WCF told me when I asked him why is the level so low, okay? So be aware of the throttling level and test it on your servers in your production environment to see how high you can set that setting. You get additional performance counters in WCF4. If you didn't know, WCF has performance counters that you can use to see how many calls are currently handled in your service, how many calls were dropped, how many sessions you currently have in MSMQ or transactions, that sort of stuff. WCF4 added a couple of more performance counters regarding throttling. It has percentage counters to show you how much of the throttling you used so far. An additional feature of WCF is that WCF now uses ETW. ETW, event tracing for Windows, allows you to automatically get tracing information from WCF without even turning it on. Okay, today, if you want to get trace files from WCF, you have to configure your service to use trace listeners, .NET trace listeners. WCF uses ETW automatically. All you need to do is go to your event viewer, tell it that you want to start listening to WCF events, and you can start see all those trace logs in your event viewer automatically. You don't need to shut down the service in order to change the configuration. Okay? Automatically in runtime. Another option of WCF4, byte stream encoder. If you need to use your service to return, say, video files, large video files. Anyone try to serialize a video file to XML? It creates a base 64 byte array, which is about 3 times or sometimes even 10 times larger than the original byte array. Okay? Now, in WCF, you can create byte stream, simple byte stream bindings that can take a file and just pass it as is, okay, without transferring it into XML, doing anything to it. WCF4 supports WS discovery, meaning you get discovery options with UDP in WCF4. You can probe the network to see if a service is somewhere in the network and get its address. You can get a service to notify you when it starts and when it shuts down. Okay, actually get a UDP message, I am service X at address Z, I was started. Okay, so you can know each service state in your network. And if you ever had an issue with serialization of derived types, anyone ever used the known type attribute in the contracts, known type for data contract serializing, to tell your base type which derived types it can expect, okay? So instead of doing that, you have a new class in WCF4, a data contract resolver, which makes this entire mapping between CLR and XML much more easy, okay? Just one class that you need to inherit from, and you solve your entire issues of inheritance in WCF, okay? So most of what you've seen is the new features of WCF4. There are a bit more features. You can read about them in my blog. The address is below there. There are many, many new features in WCF4, mainly performance features. There are many features in WCF 4.5. I do hope that you will move from WCF 3.5 to 4 and catch my session on the web that I did about WCF 4.5. It was recorded, so it will be online, I guess, in a couple of days. You can see it if you haven't been to the session. And if you have any questions, I'm here. We're out of time, so you can just come in and ask me during the break. We have lunch now, so if anyone wants to see the demos from the WCF 4.5 sessions, I'm here. Okay? Thank you very much for listening. You didn't ask many questions, so I guess that either you fell asleep, either you're very interested in the session, or you simply have no questions to ask, which is not logical. So thank you for coming. I hope you enjoyed my session. I hope you will use WCF4. And my session is already online. You can download it from, where is it? Oh, it's not here. bit.ly/gids 2012. You can download the session, all the demo that I showed. Just grab it and use it. Okay? Thank you for your time.